Okay, so some time ago I asked for suggestions and people requested more retro games. So we're going to look at Dig Dug. Dig Dug was a game where you had a little character that moved in a 2D plane, so just up and down, left and right, and they were in a subterranean environment. So there was the bulk of the screen was ground with just a little bit of surface space at the top. And as they walked around, they removed dirt, and they had two ways of beating the enemies that were traveling around. One, there were several rocks that if they dug under the rock and the rock fell on the enemy, it would defeat an enemy. The other thing that they could do is they had like a hose, a pump that they could shoot out, hit the enemy, and pump them up. So obviously we're not going to deal with all that in the first lesson. It's going to take several lessons. And at first, the character really isn't going to have any animations. Don't be discouraged by that. The very nature of game design is that you have to create a proof of concept. You take placeholder graphics, and then you wrap the code around that to make sure that it's actually working. Okay? Once you do that, then you can have people make your final graphics. But you always want to make sure that what you're trying to do is feasible and scalable, and that you can make a full-fleshed game out of it before you go in and start commissioning people to make your artwork. So what we've got here is placeholder art. So what we're going to do is we're going to take the image and we're going to put it in here. Now, the simple thing to do would be able to take this image and copy it a bunch of times. Problem is this is going to make it really cluttered. So even though it would be simple just to copy and paste here, I'm actually going to show you how to do it using code and using something that's known as Instantiate. So you're going to create an object, we're going to drag and drop it, put it down here, and that creates what's known as a prefab. Once you have a prefab, you can instantiate that over and over and over again. So you'd use that for, say, instantiating enemies or instantiating bullets or anything like that, something that you need to have be able to create on demand. So you'll look at this and you'll say, well, gee, it's white. Shouldn't it be like a dark color? And you'd be right. Now, one of the things that you can do to save work is you can use color blending, or maybe you might want to call it a palette swap, where you take an object and without having to redraw it, you just designate a different color, and voila, you have a new image. So let's take this, we'll copy it and we'll paste it, okay? Now over here shows the inspector, and this shows the various components. It has a transform component, has a sprite renderer component. So say you click on this object, and click in color, and we choose something that's a little bit brownish, okay? Now if you click on this one, click on this one, click on the color, and maybe take something that's darker. Because in Dig Dug there were like 3 or 4 different colors. And then we'll copy it one more time. He'll make this like, say, a black color. Well, no, that's not black. Make it blackish. Okay, so you have darker color as you go deeper into the ground. You can choose whatever color palette you want. Obviously, I just kind of randomly grabbed some colors. So let's call this, let's see. We'll just use a number. We'll call this 1. We'll call this 2. And we'll call this 3. And what we're going to do is we're going to make 3 separate objects. Now, this is going to make up the ground, but before we go any further, your character has the ability to dig through the ground, okay? So that means you need to be able to detect collisions. You need to be able to detect a collision with your player and the ground needs to disappear. So to detect collisions, you need something that's known as a collider box. So if we select all 3, I did that by clicking on one, holding select, and clicking on the bottom one. Click on Add Component, because as I said, these are called components. You choose Physics 2D, and you click on Box Collider 2D. It's hard to see, although this one is not too bad. You can see like a green outline. So they all have like a green outline. It now has a box collider. Each has their own individual one. Go ahead and click on Trigger, because we want it to be a trigger. What's a trigger? Well, think of it this way. In a 2D game, all right, say it's a top-down game and your character's walking on the floor. Say there's a trap door. If you don't have this set to trigger and they bump into the trap door, they can't walk over the trap door. It's a solid object that they can't go over. By setting as a trigger, they could walk over the trap door, and then you use code that says, okay, the trap door falls out from under them. So in that case, you want to detect a collision with the trapdoor object, but you don't want it to stop the person. You want the person to be able to walk over it. Conversely, say it's a table. You don't want it to be a trigger because you want them to bump into it and not go any further. So triggers detect collisions but do not impede movement, whereas a non-trigger, where that's not set to trigger, is a solid object, like two cars crashing into each other. All right, so what we're going to do is we're going to eventually add a script to these to control it, but the script wouldn't make any sense yet. So we're not going to do that yet. We've got the basics, though. It has a color. It has a collider box. So we're going to take these, and we're just going to drop them down here. Doing this turns it into a prefab. You can now use these over and over again. So let's go up here and delete these. We're now going to create what's known as a Game Master object. Now, to be clear, a Game Master object, there's nothing special or magical about it. It's really just an object that you've created for the purposes of kind of collecting functionality that really doesn't go anywhere else. It's functionality that really isn't associated with any one object. It lets you kind of collect all this gameplay and game flow onto one object. So again, calling it GM or Game Master doesn't affect the object at all, and there's really nothing special about it. It's really just that it reminds you, the designer, what you're using it for. So create empty. We'll call this GM, and it's not going to have a sprite object. Like if you click on these, they have the sprite renderer, okay? It's not going to have a sprite renderer. This, again, is not going to be seen, and really it can be anywhere in the screen, so we're just going to push it off to the side. So we're now going to add our first script. So like I said, I could, if I wanted to, take this, copy, paste. Don't do this. I'm just making an example. Copy, paste. Line these up manually and say, okay, there's, the level of dirt, and keep going out. But as you can see, this is going to get really cluttered really quickly. So we're not going to do that. We're instead going to take some code that makes the GM object aware of these objects, and then using what's known as the Instantiate command to create them over and over again. Once you have that in place, you can then add like randomized elements and just basically create an endless amount of levels. So right-click, create C# script, and we'll call this game flow. Click on the GM object. Drag and drop game flow, and open that up. To zoom in, you hold Control and turn the scroll wheel up, and that lets you zoom in a little. So, as I said, we need to make this object aware of these. Because no matter how many objects you have in the screen, they're not really aware of each other. You have to create linkages. We do that through creating what's known as variables. So, public. It's going to be a transform, capital T. So it's a public transform variable. For those of you who are familiar with old school programming, variables used to just store values. Like there would be a numeric variable or an alphanumeric variable or a string variable. Nowadays, at least in Unity, a variable can really contain anything. It can be a game object, it can be a texture, it can be a sprite, it can be a sound file. So keep that in mind. So public transform, and we need to name it. So we'll call this dirt1 obj. Now, ending the variable with the obj is completely and utterly arbitrary. I like to do that because as you're typing, monodevelop, that's the name of this, monodevelop basically will suggest, it has an autocomplete. So when I see the list of variables come up, when I see obj, I'm like, oh, okay, that's an object variable. So again, nothing absolute or magical about it. It's just another hint that you, the designer, give yourself. So public transform dirt object one, dirt1 object. And now just to save a few seconds, rather than manually typing this out 2 more times, I'm just going to paste this in. I already had copied it from another file. And I just use the same naming convention, dirt2 obj, dirt3 obj. Save it and watch what happens. So here's the GM object with the script attached. There's the 3 variables. So what you do is you take your objects and you just drag and drop them. You have now created a linkage. The GM object is now aware of these objects via the script. It can now make changes to them via the script. And that's what we're going to do. So what I'm going to do here is going to be temporary. But it's going to, again, demonstrate how this works, and then we'll go back and put in more permanent code. So for those of you who are unfamiliar, the start section gets executed precisely once, and that's when the object is created. Some objects are created when the game first runs. Some objects get created partway through the game, like an enemy gets spawned partway through the game, or a bullet gets shot partway through the game. So when that object gets created, gets spawned, this would then run, but it would run only once. So like maybe you're using this to set the starting speed and velocity and direction of a bullet or an enemy, that kind of thing. Or maybe you're setting a timer that it's going to get destroyed in 30 seconds, whatever. So this gets run when an object is spawned. Now the proper term is instantiate, if I could spell. So we're going to instantiate an object. What are we going to instantiate? We're going to instantiate the dirt1 object. And this is what I was saying about when you have a list with variables. Now there's only 3, so it's obvious what I want. But if you start getting, like I said, dozens or even hundreds of variables, it helps you to recall not just what the variable, what it does and what it is based on suffixes like that. So dirt1 object. So with the instantiate command, you have to declare 3 things. What is being instantiated, where it's being instantiated. So it's going to be instantiated in an XY coordinate known as a vector 2. So I believe it's -8, comma, I believe +3. And then you have to declare the rotation. Rotation isn't such a big deal in a 2D environment, but you do still have to declare it. So we're going to say, okay, well, use dirt obj's own rotation. Save this. Now, if you want to give your program a test run, what you do, first make sure there's no errors down here. And then here is the play button. And there's your piece of dirt. Now it's kind of, not lined up quite right, so we'll probably push that over a little bit. But basically this is the way that DigDug was set up. There was only a little bit of space at top because the bulk of the area was the dirt. Now the best way to do this, okay, is going to use a for statement. Basically, you say for as long as a variable is equal to a certain value, do this over and over again. But I don't want to quite jump into that yet. So what we're going to do is we're going to copy this, paste this, and we need to line it up vertically. So this is the horizontal, this is the vertical. So negative to positive, negative to positive. So if we want this one to be a little bit lower, we'll say put it at 2. See, now you have 2 rows of it. I think that's overlapping it a little bit. So let's get into decimals. So let's make this negative 8.2. Now, when you use a decimal, you got to drop in the letter F or you'll get an error message. Why F? I couldn't tell you, but it's one of those things that you just do it. If you're using a decimal, use the letter F. So let's make this like 1.7 F. Now, one of the things that you can do is you can try to change the size of the square so it lines up nice and neat and evenly, but it shouldn't necessarily be easy to code. You want the characters to be the right size. So you might wind up shrinking everything so it's too small or making everything too big. So you have to be careful about making things too easy on you, the programmer. You ultimately want a good experience. So that's a little bit too big. So let's make this 175. Save it again. Okay, almost there. Now what we're going to do, going to copy these two. So this is rows 1 and 2. This will be rows 3 and 4. So that means this needs to be even further. So like I said, this isn't a pretty number to work with when you're trying to do the math because it's a difference of 1.23. So that means this has to be 1.23 below that, which makes it at 0.54 F and 0.54 F. And we make one other change. This is going to be the dirt2 object, dirt2 object, dirt2 rotation, dirt2 rotation. Now, I'm not trying to confuse anyone by copying and pasting. I'm just trying to impress upon you that, yes, I wrote a couple more lines of code, but it's the same idea. We're not introducing any new functionality. Let's run that. And made an obvious mistake. What did I do? This and this are the same. This should actually have been another 1.23 below that. So 1.23 would be point. So now we get into the negatives. So negative 69, I believe. So 0.69. There you go. So now you got 2 rows there. And now you make, I know you're saying it's just one square, it's not a row. Like I said, we're going to get into making the rows in just a minute. And then this will be dirt3 object. This will be dirt3 object. This will be, so if we're at negative 0.69, so another 1.23 would be negative 92. So negative 1.92, and then another 1.27 on top of that, so that would be 3.15. Again, like I said, if you find doing this kind of math annoying, feel free to try to change the size of the objects a little bit. Like I said, you just have to be careful. You don't want to make the objects too big and have too little playroom or too small. You know, you're really trying to, I hate to say artistic integrity with graphics like this, but like I said, you have to be careful that if you go down the route of making something really easy for you, the programmer, you may wind up making things less than optimal for the player. Great. So you can do something like maybe have this one be 3 rows deep. I don't think the coloring really had any effect in the game. I'm pretty sure it was purely aesthetics. So let's make it 1 more deeper. So we'll copy this, paste this, and this one will be another 1.23, so that's negative 438. Now, once we start destroying these as the character's walking around, if it turns out that there's overlap, this is not written in stone. You can come back and change this, okay? And that's actually quite common. When you're first making your game, you're going to make mistakes and you have to tweak things so they work right. I'm sure you can think of a bunch of AAA games right now that had huge development teams that still had bugs, little glitches, little clipping issues. So don't knock yourself out. That's just the nature of game design. That, yes, you're going to make a mistake and then you have to go back and fix something. It's better to fix it early, though. So there we go, and that goes off the bottom of the screen, so that's fine. So one last thing to this lesson, and like I said, we're going to add the for statement. So let's now add what used to be known as a for next loop. I think it's just called a for loop now because you don't actually need the word next. That's really a throwback to years and years ago, like in BASIC. For BASIC, it was called a for next loop. So you might still hear some people refer to that. So in the start section, we're going to just paste this in because it's too easy to make a mistake. In fact, I spliced the video because I wanted to double check. So for, okay, float, I'm declaring the type of variable. It's going to be a float. So just as these are transform, and you can use an int, you can use a sprite, you can use various other types. This is a float, so that means it can have a decimal. XPOS, I named the variable this. So this is the type of variable. This is the actual variable name. I'm calling it that because of how I'm going to use it, which you'll see in a second. Equals negative 8.2f. Well, that should look familiar because we just said that's the horizontal position. So that's why it's called XPOS, because it's going to be the X position, the X location. Semicolon, XPOS, so again, the name of the variable, less than 8, semicolon, XPOS plus plus. I can't stand the way this looks because it's gibberish, but here's the explanation. It says that the float type variable XPOS will start with a value of negative 8.2. So long as it's less than 8, increment it by 1. This is very old coding, this plus plus. The original C programming language, plus plus meant increment by 1. And a little bit of trivia, that's why C++ is called C++ because it's the next iteration. So it's C plus 1. So even the name of C++ was really kind of a, I don't want to say an in-joke, but it was a reference to the language itself. Okay, so clearly what we're going to do is we're going to take this and replace this. So rather than having a constant, we're now going to have that variable. And just rinse and repeat. For some reason, it doesn't like that. Did it the first time. I think the reason why it doesn't like it is because this is not in brackets. So make sure that whatever follows your for loop, okay, so this is the for loop, every time this gets incremented, everything between the subsequent brackets will get repeated. So this starts at negative 8.2, these all execute. Gets increased by 1. Negative 7.2, these execute. Negative 6.2, these execute. Sorry, not trying to repeat myself, but I just want to give you, if you're not familiar with the way this works, that's the way a for loop works, is that it gives you a range of numbers, and as long as that range is occurring, you want something to happen. So basically what you're doing is you're drawing these over and over and over again. Yeah, now it's saying it. Don't put an F after the variable because the variable itself contains the F. So yes, I could have showed you this originally, but honestly, I think the for next loop in itself really requires introduction, and so that's why I wanted to show you how Instantiate works first before complicating it with the for loop. And really, that's how game development often works out, is that you're trying to make a proof of concept, you're trying to see if you can make it work, and then you go back and optimize. You go back and make the code more efficient. I mean, like just Andromeda just came out, and with Andromeda, they're releasing some code to take care of some glitches and some animations and things like that. So you're talking a AAA game, multi-year development, and it still had glitches. So don't knock yourself out. This is just the way the process works. Okay, so watch what happens now. And there you go. You now have your ground. Doesn't look awesome, but it's also meant to be a retro game. You know, we have a little bit of lining up issues on the side. There's things you can do about that. You know, maybe if you want the space to be exactly the same size, you could start at maybe negative 8.1, and that pushes the whole thing over a little bit. Your choice. Again, this is really just to get you going. You can fine-tune those kind of things because honestly, the fine-tuning can take almost as many hours as the broad strokes. So I think that's about it for the first lesson because we've shown you how to create the play field, at least to begin with. The second part is this creates a solid play field. Well, for those of you who are familiar with Dig Dug, you know that that's wrong. Let's run this again. In the center, your player is going to be here, so we need to destroy one of these. And then there's monsters like to the left and right, so we need to create some passageways there. So the next lesson is going to deal with creating the passageways, and maybe I'll even begin with character motion, but I'm trying to keep these lessons as self-contained as possible rather than like overlapping 2 or 3 different topics. I'm trying to focus on just one topic. So that's how you create your environment. And now, like I said, the second lesson will deal with creating the passageways, and we'll probably do the same thing. We'll manually destroy the passageways the first pass through, and then we'll come up with coding that say can create randomized passageways. That way you could have dozens or even hundreds or an unlimited amount of starting scenarios. So that should do it for the first one.